I think in this talk, I wanted to take a quick step back and introduce what Korifi is a little bit, and also talk about a few things that I think we with the time. Um, begin with this talk is slightly different from the entire team of the conference. All of the presenters are going to be talking about big Cloud Foundry installations and larger number of apps and things like that. I'm going to buck the trend a little bit and talk about how you can get Cloud Foundry on smaller and tiny Kubernetes instances for a change. So this idea came about when people were discussing about what they were seeing as a vision for Cloud Foundry and what they wanted to achieve with the newer ways in which you can put your foundation and Kubernetes and where you can take this. And so I think there's some people in the room that probably did this and everyone we wanted a way, we wanted for Cloud Foundry to be available on smaller compute instances. Okay. So we wanted a way for Cloud Foundry to be available on smaller compute instances in addition to being available on the large platforms that it traditionally is available on. And one of the important themes of Korifi that we've discussed about all of the different places we've been at is can it work on the large Kubernetes clusters? And we've been sensitizing audiences about yes, it does work on larger clusters, but it also works equally well on the smaller clusters. And so the 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 idea behind picking K3s, I'm sure a lot of people here are already aware of what K3s is. Yes, if I go into the details, it will delay lunch further. So I'm not going to go into the details. But it's K3s is designed as a lightweight Kubernetes instance that has all of the components of a traditional Kubernetes cluster, but it also has swapped out like a lot of different components for in order to be fully functional, but yet not create the same footprint as a traditional Kubernetes cluster. For example, it uses a SQLite instead of an etcd. It uses local storage provisioners in some cases, and it uses them instead of persistent volumes and things like that. And so that allows K3s to be installed on edge compute devices and IoT devices and the like. And so my experiment really began with if I can get Korifi installed on a K3s, and if K3s goes on to IoT and edge devices, then I think we could make like a 1+1 = 2 conclusion here. And so yeah, I'm going to again skip this for favor of getting to lunch soon. But you remember all those ugly looking Helm commands that Julian just showed a little while ago? Let's see if those actually work, right? So the first step I'm going to do is I'm going to kick off a installation of K3s. And I'm running this locally on my laptop. Again, the reason K3s is very suitable for smaller workloads makes it perfect for creating a demo cluster or a development cluster and using it for the quote unquote inner loop for a developer. So if you wanted to try something, you could. So K3s has been installed. What I'm going to do next is export this configuration. Let's see. So one of the things that I learned with my first set of experiments is that you have to disable traffic, which is the native ingress controller of K3s, because we tend to use Contour instead. And I had a tough time realizing that if I didn't do that, then it's not going to work right. So the first lesson in my many experiments was to disable traffic. The second thing was, by default, the kube config is not written to a config file that's readable for K3s. You have to specifically mention that, and then you follow that with the export command for where you want kube config to point. Um, there's obviously a few prerequisites for making this work, which is get CFCLI installed, get kubectl working, and then the next steps are applying certain YAML files. So YAML engineering is a given if you're working with Kubernetes at all, and we begin with like cert manager. Um, so cert manager is the first step. The next one is you get Kpack installed. Let me just move this around. So Kpack is going to be the build service that is on the Kubernetes cluster itself. I can, let's see. I'm going to open up a K3s. So this is the work on the cluster is visible. So you can see here that the cluster is ready and stuff gets spun up as we work through it. So there's a couple of namespaces that we need to create next. So there's the CF namespace and the Korifi namespace. So once all of that is done, we move on to installing Contour for Ingress. So this step I found a little tricky also, because when I ran commands to just install all of the namespaces, like I would apply one after the other, what would happen from time to time was the default load balancer would get enabled because Contour would not have enough pods ready and stuff like that. And so I found that we had to stage this one after the other. What we'll be doing next is creating secrets, because the Korifi installation will make use of um, artifacts that it builds and deploys to an artifact registry, and then will pull them when it has to run. So in this case, we're going to make use of a Google artifact registry. Sorry, my copy paste skills are very basic. So we create the set of credentials that Korifi will make use of, and let's actually run the Helm chart. So there's a bunch of things that you have to configure right, and um, it took me a few tries in order to get some of these working. So even like the command to create the registry credentials, you have to pass the entire sort of thing as a single key. And so that took me a while to figure out. And then there's very specific formats for the container repositories and the build repositories, the prefixes, what have you. So we can see that things are spinning up and we're not in like an infinite wait loop. Um, I wish there was a way we could specify that, this is a pre-lunch session, so make the install faster or what have you. But what happens is a bunch of different pods are created. Um, the API deployment and the Korifi controllers are what orchestrate the entire workflow of creating the app and deploying it and so on. Once this gets deployed, we can then switch to a more Cloud Foundry native set of commands, which is just basically using the endpoint to log in and um, do a CF push after we create like an org and a namespace and things like that. So this is the final pod that needs to get created. So what I wanted to also let folks know, I mean, later in the talk is there's some work that needs to go into how Korifi is able to build ARM based workloads. So right now this is working obviously on a more x86 native architecture, and so we're able to go through the demo. But if in future we intend to make use of this on smaller devices and edge devices and IoT devices and things like that, support needs to be built into Korifi in order to be able to export its workloads that are compatible with ARM or I don't know, RISC-V or whatever crazy stuff that we decide to end up using on those infrastructures. And so there is still some work to be done. There's obviously work that's ongoing, but there is definitely work that needs to be done in order to make that possible. So the installation just completed now. Um, let's begin by setting the CF API. Okay. Um, so one of the other things that I wanted to point out is CF, once you've installed Korifi, Cloud Foundry makes use of Kubernetes native RBAC from that point onwards. And so um, it uses whatever's used by Kubernetes clusters in order to log people in. So let me create an org. Yes. Um, okay. Then let me create a yep. Thanks for that. So I'll make use of this target. Okay. And then yeah. So to whichever contributor who contributed the tests in that working directory, thank you. for okay, so that's the legendary CF push, and if that gets deployed, obviously the workflow is very similar to what you probably experienced, but the one tiny change between what we see on Bosch-based CF is this is going to make use of Paketo build packs in order for the builds, and then it will stage it using um, the the run workloads and those controllers on Korifi. We can take a look at some of that in the different spaces that are there. So you can see that namespaces for the org and for the space have been specifically created. Um, mm, so this is the logs from the pod that's responsible for the build. Um, so this is logs that basically specify that the Paketo lifecycle gets kicked in, and okay. Um, we'll break, and hopefully by the time we're back from lunch it builds. I don't know. So it's definitely faster when I tried it this morning, I promise. But um, yeah. So anyhow, the last part of the demo is just this running and then returning a URL. But let's break for lunch, and this can be a very entertaining thing at a developer conference. A build is going on, and but yeah, thank you. And